Hey, hello world. My name is Pruthviraj and welcome to my YouTube channel Bionic Bee. On this channel, I'll be presenting my ideas for all the guys who really enjoy learning data science and AI. My goal is to inspire you guys to get creative in the field of AI and have fun trying new ideas and reading research papers. Be sure to hit that subscribe button down there so that you don't miss out on any of my videos. Thanks for watching. So hi guys, today we have a very interesting topic. Why should we add layers to a CNN model? We add layers to a CNN model to increase its stability to learn or represent more complex features in the input data. So what it means is the image data what we have is actually complex in nature because when we cannot define a specific object in the image with certain rules, then we say that it's a complex image. Maybe for one image you can define, but for the image group you cannot define certain features, right? For example, let's say I want to use a image of phones, right? If I use certain rule based image, maybe the image what you have taken, the color of the phone is green color, right? But maybe somebody else have used a phone cover and the phone they have taken, the color is different. So if you have used a filter based approach, or if you have used a strict rule based approach to tell whether this is a phone or not, then it's going to be difficult to generalize or to identify phone in any of the images. So we need something which can represent more complex features. Apart from that, it also extracts specific set of features from the input image whatever is given. So if we add layer, it is going to extract feature in each and every layer. So that's why. But some important points what we are going to discuss is to extract features from the input data, we add layers. That's the first thing. Now we know that in every layer the kernel is responsible for extracting features from the input data and creating feature maps, which you can say channels as well. Now if we add more layers to it, then it is going to extract more features, right? The second point what we can tell is to increase the non-linearity of the model. So if we know what is non-linearity, for image the non-linearity in nature means that the relationship between the input features and the output feature is not a simple or straightforward one, right? Instead there may be multiple and complex interaction between different features that contribute to the final output of our image. To increase the non-linearity of the model, we add layers into the model. What it means, why do we need non-linearity in a convolution model? As I have already mentioned, if you make some rules to define a picture in a image, that rule might not be satisfying for all the image in the universe, right? So it is difficult to do it very straightforward. That's why it's non-linear in nature. So by adding multiple layers, we try to extract non-linear features from the image, and that's why it can use for defining more non-linearity in a convolution neural network. So that's also one of the important point. Then the third point what I can tell is to improve the model's ability to generalize, right? It's like the more feature you extract, the more you know about the object we are trying to detect or classify. Because we have more data, then we can extract more deeper insights. For example, if we see or if we are trying to detect a dog, let's say if we see a dog nose, then probably we can say that it's a dog, or a complete face of a dog, then we say that it's a dog. To extract such features, we need to build a deeper model which can so that in every layer it's going to extract some of the features from the image and then it passes on to the next layer, right? And the fourth and also important point, and a very careful one, is to reduce overfit. As we know, any machine learning model, if we are using more parameters in our training, or if you are going to use more layers or more number of kernels in a neural network, it is going to be overfitting. So we need to have certain amount of layers in a specific model what you are trying to develop, so that it will not be overfit, and it will also extract as many as features it need. So we have different techniques, of course, to handle overfitting. Like we have dropout, we have different regularization technique. Weight decay is one of the regularization technique I have already mentioned there. We have batch normalization as a regularization technique. So we have all of them to reduce the overfitting. But if we add more layers, it also reduce overfitting, given we know how many layers we need to add. Though there is no specific answer to it, but it comes with experience. When we are creating or building a neural network which is more complex in nature, then we have to go deeper, as much as deep it's possible. So this concept is also related to the concept of receptive field, and we are going to talk about it. But apart from these 4 points, there is one more point which is most important. Let me give an example. Let's say if we want to detect a car, how can we do it? If we are able to detect a wheel, if we are able to detect a radiator, a car engine, a front headlight, then we can say that it's a car. Now, if we talk about each and every part of the car, let's say we are trying to detect a headlight. If we are able to know the edges and gradients of headlight, like the shape of the headlight, or like the color of the light, then we will be understanding what is the light. Now, similarly, in the same line, if I give one more example of tire, if I understand how a tire looks like, then I can tell this is a tire. Like I need to understand. I need to identify that it's a tire. For that, I need certain feature to be extracted in the tire, right? So to identify a car, we need to extract the part of the car, which is like wheel, headlight, etc., etc. To be able to understand what is a wheel, what is a headlight, we need to understand more detailed feature of a car. And to understand the more detailed feature of a car, we need to actually have something which can extract information about it, right? So what in the other language, what I can say is, if you look at this left example over here, to do a face detection in the very first blocks of layer, we are trying to find out edges and gradients of an image, right? So the kernel we are training in the initial blocks are basically trained to extract edges and gradients, and later blocks it extract a little bit more complex feature, which is textures and patterns. Then in the third block, it is extracting part of objects, just like you can see here. Here we are extracting a human face, human nose, somewhere around lips and eyebrows and all these things. Here also you can see some car parts, like here the front, the back wheel, the front wheel, the bumper, the sunroof, and all. It's trying to extracting. Here it's an elephant detector, the trunk of an elephant, then the head, the ears. Then so basically we are in the third block of layers, we are trying to extract parts of object, and in the final block we are extracting the complete object. By looking at the complete object, we finally decide what this object can be. So if this diagram is about a multi-class classification, which like we are trying to detect a face or a car or elephant or chair, then every kernel is designed or back propagated in such a way that they are able to extract edges and gradients, textures and patterns, part of object, and objects are being extracted in the last layer, so that in the last layer we will be able to tell what is this object is all about, whether it's a face or it's an elephant or it's a chair or it's anything else, right? So that's why, as I said, we have 4 blocks. That's why we add multiple layers to the convolution neural network, so that it can extract those information and give it to us. There is a research which says that in a 400 cross 400 image, to understand the basic features about the image, we need 11 cross 11 pixels. So if we take any of the picture which is 400 cross 400 of size, and we kind of zoom into it, then we see that if we count approximately 7, 9 or 11, within the 11 cross 11 area, we see parts of object mostly. So now the intuition what we can take from here is, in the initial block, we need to convolute in such a way that we can at least cover an area of 11 cross 11 while the image size is 400 cross 400, right? So this concept also is related to the receptor field, which is which I'm going to discuss in the next video. But yeah, we need to take care. But yes, we always need to think while building a neural network that what is our receptor field, right? Because receptor field is really plays a major role to give information in each and every layer. So with this, we conclude this video. We add layer to extract features from data. We add a layer to increase non-linearity of the model. Then we add layers to improve or to generalize our model better. We add layers to reduce overfitting, and the most important, we add layers to extract edges and gradients, textures and patterns, part of object, and finally the objects. With that, thanks for watching this video.